Imagine a space so dense and powerful that not even light can escape. A place where gravity is so intense that anything that approaches its boundary, known as the Schwarzschild radius, is inevitably drawn in and disappears forever. This is a phenomenon of black holes. But today, we're going to talk about a very special and even more mysterious type: supermassive black holes. These cosmic giants, which inhabit the centers of nearly all galaxies, are by far the most impressive black holes. While regular black holes have a mass several times that of the Sun, supermassive black holes can have millions or even billions of times the solar mass. But as intimidating as these numbers are, what truly fascinates scientists is how these cosmic monsters influence everything around them, shaping galaxies and altering the movement of stars in ways that we are still trying to fully understand. Imagine the center of a galaxy, a region where stars move at incredible speeds, and suddenly, you realize that at the heart of this chaos, there's a gravitational force dominating everything around it. This is the presence of the supermassive black hole. It's like the center of a cosmic whirlpool, with its immense gravity pulling everything toward it. The impact of these black holes on the movement of stars is astounding. As stars approach the central region of their galaxy, the black hole's gravity begins to affect their trajectories. They don't move freely, like stars further away from the center. Instead, they begin to follow more complex orbits, rotating around the black hole at incredibly high speeds. Some even move so fast that their motions become almost impossible to predict. And even more astonishing, these stars can be traveling at millions of kilometers per hour as they get closer to what we call the event horizon, the point of no return for the black hole. But the influence of these black holes isn't just limited to stars. They also have a profound effect on the shape of galaxies. The immense gravity of a supermassive black hole can alter the galaxy's structure, distorting the distribution of stars and even interfering with the formation of new stars. Like an invisible force, it can stretch the galaxy into a more elongated shape, distorting what could have been a perfect spiral into a more irregular form. This distortion process can be seen in what are called elliptical galaxies, which often appear flattened or oval due to the dominant presence of these black holes at their centers. In some galaxies, supermassive black holes even accelerate the fusion of stars, creating a region of intense activity and star formation near the center. But what happens when a supermassive black hole goes into action? In certain cases, it not only influences the movement of stars around it, but can also release an immense amount of energy. When matter falls toward it, it doesn't simply disappear. Instead, it forms a rotating disk of material, heating up to the point of emitting radiation, so intense that it can be seen by telescopes billions of light years away. This phenomenon is what we call a quasar, one of the most powerful sources of energy in the universe. However, despite all this power, many supermassive black holes remain mysterious. They not only dominate the center of their galaxies, but also influence the fate of the entire galaxy. Scientists believe that supermassive black holes may play a vital role in the evolution of galaxies, possibly even controlling the amount of matter that can be accumulated and, in doing so, limiting the formation of new stars. So, the next time you look at a distant galaxy, remember that at its heart, there might be a supermassive black hole, influencing not only the gravity of the stars around it, but also the shape and fate of the entire galaxy. They are like invisible giants, whose effects can be felt throughout the cosmos, sculpting galaxies in a way we are still trying to uncover. Have you ever stopped to think that, in reality, we know almost nothing about most of the universe? Yes, you heard that right. Although we've uncovered many secrets of the cosmos, there's an invisible substance that makes up about 85% of the matter in the universe, and no one knows exactly what it is. This mysterious substance is known as dark matter, and it is one of the biggest unresolved questions in modern physics. Now, imagine this. We are used to thinking of the universe as something made up of stars, planets, gases, and cosmic dust. But in reality, this represents only a fraction of what's truly out there. Everything else, over 80% of what makes up the universe, is something we can't see, touch, or measure directly. And the most fascinating part, this dark matter does not emit light, radiation, or any other form of energy that we can detect with our telescopes. It simply doesn't interact with light. It's like a shadow extending throughout space, but a shadow that we cannot see or fully understand. So, how do we know it exists? Well, despite being invisible, dark matter has a very real presence. It exerts a gravitational force on the matter we can see, like stars and galaxies, and it's this gravitational interaction that has revealed its existence to scientists. For example, by observing the movement of galaxies, we notice they are spinning faster than they should be, based only on the amount of visible matter we can see. It's like watching a carousel spin, and suddenly, the movement is much faster than the amount of visible energy that should be driving it. This means there's something invisible that is pushing these galaxies to spin faster, and that something is dark matter. Now, imagine you are observing the cosmos on a larger scale, say, an entire galaxy. Scientists have discovered that visible matter, like stars and gas, is distributed in a spiral or dispersed pattern, but it's dark matter that really holds the galaxy together. It forms an invisible web around galaxies, like a cosmic net, and it's this web that keeps the galaxy intact, preventing it from falling apart due to its own rotation. In other words, without dark matter, galaxies would likely scatter, as the gravity of visible matter wouldn't be strong enough to keep them cohesive. However, even though we know dark matter is there and we observe its effects on the movement of galaxies, we still don't know what it is. We don't know if it's made of unknown particles, or if it's tied to phenomena we don't fully understand yet. There's a fascinating theory that dark matter could be made of particles called WIMPs, weakly interacting massive particles. But to this day, we've never been able to directly detect these particles. What makes dark matter even more enigmatic is the fact that it doesn't interact with light, which means we can't observe it with telescopes or cameras. It doesn't reflect, emit, or absorb radiation. That's why it remains invisible to our instruments. The only way we see dark matter is through its gravitational effects, which leave a mark on the movement of galaxies and other celestial bodies. And the mystery doesn't end there. Another exciting concept is the relationship between dark matter and dark energy, another mysterious substance responsible for accelerating the expansion of the universe. While dark matter pulls things inward, dark energy seems to be pushing the universe outward, causing it to expand faster than expected. Together, these two forces, dark matter and dark energy, make up the majority of the content in the universe, yet they are completely invisible and elusive. As new, more powerful telescopes and sophisticated experiments continue to be developed, scientists are getting closer to understanding the true nature of dark matter. They are looking for indirect signs of this substance through experiments in particle accelerators and even observations in deep space. But the truth is, no matter how much we advance, dark matter remains a major enigma that challenges our understanding of the cosmos. So, the next time you look up at the sky and see a distant galaxy, remember, what you're seeing is just the tip of the iceberg. The majority of the universe, more than 80%, is hidden, invisible, and waiting to be discovered. And dark matter, with its secrets yet to be unraveled, continues to remind us that the cosmos is far more mysterious and fascinating than anything we can see with our own eyes. Imagine the universe as a vast balloon being inflated over time. Since the Big Bang, about 13.8 billion years ago, the universe has been expanding. But here's the mystery. In the last few billion years, this expansion hasn't just continued, it has accelerated. And who's responsible for this? Something invisible, something that scientists call dark energy. But what exactly is dark energy? And how is it controlling the acceleration of the universe? Let's start with the basics. When we look at the cosmos, everything we see, the stars, galaxies, nebulae, is, in a way, fighting against gravity. Gravity, as we know, is an attractive force that causes massive objects like planets and stars to come together. This gravity should have a slowing effect on the expansion of the universe, or at least it should have. However, something strange is happening. Not only does the expansion of the universe continue, but it is accelerating over time, as if some invisible force is pushing galaxies farther apart. And this is where dark energy comes in. Dark energy is a mysterious form of energy that permeates all of space. It was first proposed in the late 1990s, when astronomers observed something no one expected. While studying the light from distant supernovae, these scientists discovered that the stars exploded much more faintly than expected, which suggested that galaxies were moving away from each other faster than before. Something was indeed accelerating the universe. That's when the idea of dark energy emerged. Although we can't see or measure the substance directly, the only explanation for the accelerated expansion of the universe is an invisible force acting like a kind of anti-gravity. Instead of attracting, dark energy is pushing space itself, causing galaxies to move away from each other faster, as if they're being pushed apart by a cosmic force. But here's the most impressive part. Dark energy makes up about 68% of the universe. That's right, more than 2/3 of everything that exists in the universe is made of this mysterious substance. And the most intriguing part is that we still don't know what it is. Scientists have several hypotheses, but none of them have been confirmed so far. Dark energy doesn't interact with light, with the matter we know, or with any other form of energy in a direct way. It is invisible, intangible, but its presence is there, clearly influencing the fate of the cosmos. The best way to imagine dark energy is to think of it as a vacuum energy that fills space and is tied to the very fabric of space-time. According to Einstein's theory of general relativity, space-time can bend due to the presence of mass and energy. Dark energy would be a form of energy that causes space-time to stretch, making the universe expand more quickly. So, what does this mean for the future of the universe? Well, dark energy has enormous implications. If it continues to dominate the expansion of the universe will keep expanding indefinitely, accelerating, until galaxies, stars, and even neighboring galaxies move so far away that they become inaccessible to any observer in the future. In other words, in the distant future, the universe may become so diluted that the light from the stars we see today will no longer be visible. Dark energy also raises a profound philosophical question. Does the universe have a limit, or is it destined to expand forever? The answer may lie in the nature of this mysterious energy. The study of dark energy is far from conclusive, but scientists have dedicated enormous efforts to understanding it, with the help of experiments, telescopes, and space probes that explore the deepest reaches of the cosmos. In one way or another, dark energy has changed our understanding of the universe. It has not only shown us that the cosmos is much stranger and more mysterious than we ever imagined, but it has also made us rethink the very destiny of the universe. What started as a simple observation of supernovae has become one of the most challenging questions in modern science. Dark energy is not just a physical concept. It's one of the greatest mysteries of our existence in the cosmos. So, the next time you look up at the sky, think about this. The universe is expanding, and something invisible is accelerating that process. What do you think dark energy really is? And what is its role in the grand stage of the cosmos? Only time and science will tell. Imagine for a moment that the universe we live in, with all its galaxies, stars, planets, and even our own existence, is just a bubble in a vast, incomprehensible ocean. And what if I told you that, beyond our reality, there are countless other universes, each with its own laws of physics, dimensions, and even different versions of ourselves? This is what the multiverse theory suggests. The concept of the multiverse is such a challenging idea that it may seem more like science fiction than real science. However, in recent years, this theory has gained increasing attention from scientists, physicists, and cosmologists. While it is still a highly speculative field of study, it opens the door to deep philosophical questions. What is reality? And are we really living in the only possible universe? First, it is important to understand that what we call the universe is not a fixed concept. In fact, our universe, the one that began with the Big Bang 13.8 billion years ago, is vast beyond our comprehension. It is full of stars, galaxies, and black holes. But what many scientists propose is that our universe may be just one of countless others, all coexisting in a larger reality that we can barely begin to understand. How the multiverse theory works. The multiverse theory is not a new idea. It has roots in some of the greatest advancements in modern physics, particularly in quantum physics and string theory. Let's explore some of the main versions of this theory. The first version comes from quantum physics and the famous interpretations of quantum mechanics experiments. Imagine a world where, at every moment, the choices we make do not just create one path, but multiple possible paths. In the many worlds interpretation of quantum mechanics, every time a decision or event happens at the quantum level, the universe splits. Each possibility materializes into a separate universe. In other words, every choice you make creates another version of yourself, living in another universe, having chosen differently. This means that when you look back at your life, instead of a single line of events, there are multiple yous, each existing in a different universe, with different outcomes. This interpretation may be hard to swallow, but it is one of the most accepted explanations in the field of quantum physics. Every decision, every event, may have created a new universe. Another popular version of the multiverse comes from the theory of cosmic inflation, which describes the rapid expansion of the universe immediately after the Big Bang. Imagine the universe as a foam, where the bubbles represent distinct universes. According to this theory, our universe is not the only one, but rather a bubble that formed within an ever-expanding space that contains other bubbles, each representing a separate universe. Each bubble could have very different properties. Some might have laws of physics different from ours, others could have much stronger or weaker gravity, or even entirely different dimensions. Universes could be far more varied than our imagination allows, with some possessing completely different forms of life or entirely different fundamental principles. Finally, there is string theory, which attempts to unify the four fundamental forces of nature into a single model. String theory proposes that elementary particles, such as quarks and electrons, are not tiny points but rather vibrating strings. These strings can vibrate at different frequencies, and depending on the frequency, they generate different types of particles. But what is even more intriguing is that within this theory, the multiverse could arise from different ways of compactifying dimensions. String theory suggests that our universe may have several dimensions beyond the four we know, 3 spatial and 1 temporal. And these dimensions could be compacted at such small scales that we cannot detect them. However, in other universes, these dimensions could behave differently, creating realities we can't even imagine. What does this mean for our reality? Now, think about the implications of this theory. If there are multiple universes, it raises some incredible questions. For example, are there other me-s in parallel universes? Are we living in a chosen version of our universe, where all the decisions we made unfolded in a specific way? And if our universe ends, what would happen to the other universes around it? While direct evidence for the multiverse still does not exist, the implications of this theory are absolutely fascinating. It forces us to reconsider what we know about reality, existence, and the fate of the cosmos. Some scientists believe that if we could understand how these universes might interact or even touch each other, we could open up new paths of discovery that would help us understand the limits of physics. Beyond science, the concept of the multiverse is also fertile ground for philosophy. The idea that multiple versions of reality exist can change our perception of free will. If there is a universe where we make every possible decision, it questions what is real and whether we truly have control over our actions. On a deeper level, the multiverse theory also forces us to question whether our universe is truly unique, whether we are alone, or if we are just an infinitesimally small point in a sea of possibilities. If other universes truly exist, what is our place in all of this? The multiverse theory takes us to a realm of possibilities that challenge logic, but also attract us with their promise of unimaginable revelations. Scientists are still in search of definitive answers, but the simple fact that our universe might be just one among many is an invitation to explore the unknown. The multiverse is not just a fascinating concept in science. It is a way to rethink our very existence and understand the cosmos as a much larger and more mysterious place than we ever imagined. Who knows? Perhaps, somewhere, alternative versions of yourself exist, living other lives in parallel realities, exploring other universes, maybe even discovering answers to questions we are only beginning to ask. The multiverse is a reminder that, on the grand stage of the universe, what we know is just a fraction of what is possible. Imagine yourself floating in the vast, silent space. Many of us, when thinking about the universe, have this idea that it's an absolutely silent place, where sound doesn't exist. But what you might not know is that, while space as a whole is an almost absolute vacuum, sound is not entirely absent. It behaves very differently in space than it does here on Earth. Ready to demystify this concept? Let's dive into this fascinating mystery. To understand how sound can or cannot exist in space, we first need to remember how it works here on our planet. Sound, as we know, is a wave that propagates through a medium, like air, water, or even solids. It moves through these substances by making particles vibrate, creating sound waves that eventually reach our ears. But space, as we all know, has no air. In fact, it is a vacuum, meaning it is almost completely empty of particles that could vibrate. And that's what causes the biggest confusion, the idea that sound simply cannot exist in space. The reason why sound cannot travel freely in deep space is simple. In the vacuum of space, there are no particles, like the oxygen and nitrogen in air, to carry the sound vibrations. This means that in places with little or no material to transmit these waves, sound simply doesn't propagate. So, in deep space, you wouldn't hear anything at all. But what about those images of explosions in space we see in sci-fi movies? They might create an impression of sound, but in reality, explosions in space are silent. In a vacuum, where there are no particles to propagate sound waves, there is no sound. So, those epic exploding sounds in movies are pure fiction. Where can sound exist in space? Now that we know that deep space is indeed silent, where could sound actually propagate? The answer lies in an intriguing concept. Regions of space that contain some form of matter or gas. Although the vacuum is silent, there are clouds of gas and dust, like those found in nebulae, where sound can travel in a very different way than we're used to here on Earth. In denser regions of space, such as near stars or planets with atmospheres, sound can indeed propagate. Let's take the example of nebulae, huge clouds of gas and dust that exist between the stars. In some of these nebulae, there are enough particles to allow sound waves to propagate. However, even though sound can travel in these places, it would be very different from the sound we hear in our daily lives. This is because the sound in these areas would not be audible to our ears. It could have such a low frequency that it would only be detectable by very sensitive instruments, like the sound wave detector scientists use. For example, the Crab Nebula, a remnant of a supernova, has regions where scientists have detected a compression wave in the surrounding gas, something similar to sound. But even though this is technically sound, the frequency of this wave is so low that it is far below the range of human hearing. So yes, there could be sound in nebulae, but it would be inaudible to us. Stars and sound in space. Another interesting example occurs around young stars. When stars form, they generate tremors and pulsations in the surrounding matter, which can create sound waves. The pressure waves that these stars generate can be detected in some parts of space, such as in the so-called gas cavities near the star. In some cases, scientists have detected frequencies so low that they become audible when transformed into a range we can hear. In simpler terms, it's like taking a vibration in space and converting it into an audio track. So, it's as if a type of sound exists near stars or massive objects, but it is only perceptible through technology, not directly with our ears. The sound of gravitational waves. Another fascinating phenomenon that could be considered sound in space is gravitational waves. While they're technically not sound in the classical sense, they are vibrations in space-time caused by extremely powerful cosmic events such as black hole or neutron star mergers. As these waves propagate through space, they create ripples in the fabric of the universe. Scientists have been able to hear these waves by transforming the vibrations into frequencies we can interpret. In other words, although space doesn't have sound as we know it, these waves are a kind of cosmic sound. Yet they are still invisible to the human eye and only accessible to sensitive instruments. So, while deep space is indeed silent due to the lack of particles to transmit sound, there are several situations and places in the universe where sound can exist, but in a way that is very different from what we experience here on Earth. The sound in nebulae or near stars is not something we can hear directly, but it can be detected and translated in ways that allow us to understand the workings of the cosmos in a completely new way. Ultimately, sound in space reminds us that even in the vast and seemingly silent universe, many mysteries are waiting to be discovered. Sound, in a unique and almost magical way, is still a means to explore and understand the secrets of the cosmos, showing us that, in fact, space is far more dynamic and alive than we imagined. So, next time you think about space, remember, it's not just a place of silence. It's full of sounds, but only in a way our ears can't yet directly capture. What do you think, folks? Space is truly a fascinating and mysterious place, isn't it? Now we know that the silence of the cosmos is more complex than it seems, with incredible phenomena showing us how the universe works in ways we never imagined. Thank you so much for watching this video to the end. If you like the content, don't forget to like, share with your friends, and leave your comment below. I love hearing what you think and what other curious topics you'd like to see here. And of course, subscribe to the channel so you won't miss the upcoming videos filled with discoveries about the universe and other amazing subjects. Let's continue exploring the mysteries of the cosmos together. See you in the next video.